So it's one of these days where I do have to do an overdub. I don't know why there's no sound. There's no reason for it. The preamp was on, the mixer was on, everything was right. This video is done over 2 days. The day 2 part of the video has got its original sound. I spent about 4 hours doing this radio. These are not to be compared with the 1005 and the 1001. They're vastly inferior, but they do retain the external microphone facility, which is so important. So you're going to get reduced range, even with the telescopic aerial. It's a shorter telescopic aerial, and you haven't got the range boost side panels. So from the box, it looks like it's a silver kind of finish. You might think that's part of the chassis, but it's a plastic case. And so whereas on the previous models, the 1001, the 1002 even, and the 1005, you've got the range boost side panels you haven't on this one. And the other thing is that when you plug it into the test equipment, you just do not get the kind of results you're expecting. So whether or not the telescopic aerial still connected in the circuit and the other parts of the electronics drag on it, I don't know, but you always end up with crummy looking results on receive. And at the end of this video you'll see that I compared it with our own unit, which I've owned from new, just to show that. So this is an immaculate one. It's from a dealer in Sheffield on behalf of a customer. It's probably not worked properly from virtually new. What he said in his little note is that sometimes it seems to work and sometimes it doesn't. You know what? That date code on the box isn't the date code on the radio. That box isn't the matching box to that radio. I've just noticed that. It's 08 is the date code on the radio, and that's 0. So it's got its carrying case, which is nice. It hasn't got its dummy batteries. So it's supposed to be 8 throwaway 1.5 volt batteries or 10 rechargeable AA batteries. To be honest, you could put 9 alkaline batteries in, but you would kill it with 10. So you do need dummy batteries, and if you buy those because you found they're missing, like they are in this case, if you look on eBay you will find them readily available, but they're sometimes called fake batteries. I think the Chinese translation sometimes doesn't come through, and it's the word is fake. So it's come with a carrying case, which is nice, but it does look pretty immaculate. And when I opened up the battery compartment, well, it looks like it's never been used. So the bit better range than anything currently on the market when used with the telescopic aerial. You'd have to look back on some of the on-the-air tests we've done, some of the field tests we've done. I think we'll have had more than 4 miles on one of these. So we've got it hooked up to 12.5 volts, 12.4, 12.5 volts. Put it on channel 20. It's one of those sets that annoyingly starts off on channel 9. So you need an SO239 to Motorola adapter. So that Motorola fits in an old car radio. So it's a bit different to a phono, but a phono will fit, but a phono is not as deep. I don't think these are a good connection at the best of times, so you don't want to make it worse by using the wrong adapter. So that's SO239 to Motorola. It may be SO239 to phono, depending whether the people selling it know what it is. They're readily available on eBay. You've got high-low power, which is bizarrely set. I think they've got it at 0.25 watts, but the legal position was it was supposed to be 0.4 of a watt. So it's just a bit, I don't know why they did that. Had to print off like a fool. I've printed it off without it reducing, because it's a little bit too big for the paper, so we've got a circuit there that doesn't quite fit, but I think everything else fits, but it just looks a bit bizarre with no borders on that. So luckily I had the sense to buy these service manuals. I think they were $16.99 at the time each, and you often got a photocopy, and so at least this is a first generation scan of our photocopy. So look, it's 12.5 volts, and it's supposed to be a 3.5 watt radio. Your limit spec is 3 watts to 4 watts. And low power is 0.25 watts, which is ridiculous when the MPT 1320 specification calls for 0.4 of a watt. But it's not adjustable, and the point is it is a lot lower power. It's 10 dB ish. Sensitivity is supposed to be half a microvolt for 10 dB synad, or a limit spec of 1 microvolt. But you'll see you can't get anywhere near that, because you end up with this adapter tree which is robbing some of your signal. So we know it's a realistic TRC1007, and we know that yesterday was the 3rd of March. These were £99.99 new, around 1988 to 1991, and that's a 1988 set in a 1990 box. The 2005 that it replaced was £139.99, and the 1001 that replaced was £119.99 in 1981. Did I say 1983? It should have been 1983 for the 2005. So let's have a look at the power levels. I think it's doing 2.8 watts. We've checked it on channel 1 and channel 40. You'll see that when I move the clipboard away from the inset picture. So we're on 3 watt full scale deflection there, so yes, it's about 2.7 or something like that. It's about where it should be, to be honest. And it was pretty well balanced between the 40 channels. It's about 0.1 of a watt, isn't it, that? Yeah, 100 milliwatts. $823 milliamps for its 2.8 watt output. Look at deviation. Well, it was absolutely unbelievable. The deviation worked out at 18 kilohertz. It's supposed to be 2.5 absolute maximum, averaging 2.2. You just couldn't make it up. You really couldn't. But to be honest, I think it's the only thing that's been messed with in it. But it's a faff, because you'll see later on, you've got to put a voltmeter on a test point. You've got to set that for the correct amount. Then you've got to fiddle with 2 presets to get it exactly so. It's VR1 for 1 kilohertz, and it's VR2 for the deviation you're looking for, which in this case is going to be 2.2 with an absolute peak of 2.5. But you've got to have this reference voltage first. And of course, unless you've got the service manual, you know that procedure. These have got dodgy enough audio at the best of times. The AGC, it kind of distorts on the peaks. So if you have a look at one of our on the air tests previously to one of these, or the binatone route 66 performs exactly the same way with a rather clippy AGC on voice peaks. It's virtually spot on frequency, that one. 2779129. We're not going to alter that. They drop naturally with age, and it's just about bob on. So looking back at the notes there, and it says it's intermittent. So we're connecting it there to the test instruments through the extension speaker or earphone socket. And this is one of the wonderful things about these sets, and that's the really good set of connections to the outside world that they've got. So you can use them as a base station if you want, and you can use it legally mobile, slung on the seat of your car with an external mic. So yeah, very versatile, but this aerial arrangement isn't ideal. So looking at the synad meter, and we'll start to see what looks to be dire results, but it's not really, it's just the connection. Something like 7 microvolts for 12 decibel synad. But I'd say if you could just get rid of the telescopic aerial and all the ancillary bits and pieces and be actually connected to the main board directly, it wouldn't be as bad as that. Yep, 7 microvolts. For 10 dB we've got 5.5 microvolts. For 20 we've got 18 microvolts. I think that was about 56 microvolts for full squelch, but it's not adjustable, and it does alter when I retune the receiver. So we'll just put in the threshold figure now. I think that's 1.5, 1.8 microvolts. It's quite okay. So it doesn't have an RF meter, it doesn't have an S meter. Right, so having opened the immaculate battery compartment, it's time to unscrew the 3 screws. You've got that one in the top, in the back there, then you've got 2 other ones in the battery compartment. So back to this, we're hoping we weren't going to have to take the VCO cover off because it can be a bit of a swine to put back on. But of course we ended up doing, didn't we? And then putting it back on and then taking it off again and putting it back on, only to discover the transmitter was out of balance and opening the whole thing back up. You'll have sound by then. So you can see it's transmitting absolutely as it should be doing, just going through the tune-up, and then it started playing up and being intermittent. Sometimes you could do with 2 copies of these manuals because you need the layout, you need the instructions, and so on. That is the power preset. And we've got it at full whack, and I think we get 3.1 watts. So that's having gone through all the adjustments. And that's in spec. Trying to unlatch that. Make sure you do it with the power off like I did. At least it's not full of wax. It's got a bit of hot glue wet on the sensitive bit. I didn't feel a need to do the VCO. I did later though. You just wait. So it did end up on Mr. Chippie's bench, and he's taken that screen plate off and he's been through that for dry joints. While he was taking that screen plate off, a piece of printed circuit board material fell out of it, and that piece of printed circuit board material could well have been shorting something out because it was a conductive bit. So that was another point. So, but we still weren't out of the fire yet. There were some other dry joints which were the kind of pinned through from one side of the board to the other. It's not done in there's a word for this. They're not plated through, but they're just solder rivets, and they can go dry joints, especially on those 1001 and 1005s. We're starting to have these play up, and there were about 9 of them. And you see the transmit power. Sometimes it's doing 100 milliwatts, sometimes it's doing 3 watts, and that was down to those. So there's nothing for it but to have to solder from this side. I think we're just trying to find the VCO test point at this stage. Notice how I put the meter on AC by mistake. So if I recall, you set it for 1.5 volts on channel 1 on receive only. I'm thinking, why is it giving me this residual reading? So it was slightly low when we actually got onto DC. We need to check on channel 40 that's in the voltage range which is shown. And I think it's channel 40's 4 volts maximum, like you'd expect. So we're still having trouble with it transmitting intermittently, and that's when I turned to getting the soldering iron onto those through board links. So this is where edit point 4 ends. So edit point 5 is quite a quick one. Showing some of these links that go through just before we solder them. And hopefully we've soldered these up. I think that was the worst one just there. But I recall there's 9 in total. So we've still not got it transmitting properly. So I think we have to look for a few more of those links. Let's see if we've got power now all the time. Yes, it looks like we have, and it's more than 3 watts. Let's put that shield plate back. Don't worry, we'll take it off again before the job's finished. I think it's time to move on to the deviation. Now it's the fun time. It's trying to find a test point for setting the deviation. So the idea is that you've got those 2 yellow presets towards the bottom of the screen, and that upper one of the 2 is VR2 and the lower one's VR1, and you've got to find the appropriate test point. Is it test point 6? And then with your meter you've got to turn that preset until you get the voltage stated in the manual, which I think is 2.5 volts. And then in transmitting with your oscillator or whatever you're doing to generate a 1 kilohertz tone, you need to set VR1 for 1 kilohertz deviation, and then you adjust VR2, which is the one you've preset to 2.5 volts or whatever it says in the manual. You then get the deviation you want with that one. So you've done a reference, you then set VR1 to that 1 kilohertz, so that's 2 reference points, and then you go and upset your original reference point, and that sets the deviation. So that's VR1 being adjusted. That's with our first adjustment. So we need it with reference to that. I think it's 1.5 volts or 2.5 volts, whatever it is. Oh, we're getting a voltage. Hey, we're getting there. We might see. Yeah, it's 2.5 volts. Looking at that. So I think we've got that voltage set, and now it'll be a matter of getting the oscillator out and seeing where we are and adjusting variable resistor 1 to give us the 1 kilohertz deviation. There we are, just putting that underneath where the electric condenser mic is. And if we look at the left hand meter, we can see we've got deviation. Remember, I had to bring this down from 18 kilohertz, so our initial step is to get it to 1. Wallow. That looks about 2 kilohertz. And that looks about right. So I'm just recapping here about the 2.5 volts with variable resistor 2 there, and then setting the 1 kilohertz with the tone input, and then setting the deviation that you need back with variable resistor 2, the inner one of the two. It's basically the third resistor higher than where that microchip is. So we're going to get on with the receiver now, or are we still faffing with the transmit? Right, we'll put Mr. Chippie's stolen crocodile clip away. Oh no, we're going to get on. I know what we're going to do now. We're going to put it on the spectrum analyzer because I didn't know what had been faffed with. And the final two adjustments are the second harmonic and the third harmonic. So just loosely coupling it, just put a bit of wire on the input of the spectrum analyzer. It's quite enough. So we have to dial in something like 56 megs. Because the one in the centre of the screen is the one we're dealing with. You've got the fundamental on the left, and the other one we've got to deal with on the right. So there is a coil to adjust for this. And you can see we've got that really low down. Vast improvement. So now we have to dial in the third one, which is I think it's the 86 meg harmonic. It's a little coil. This is what I'm having difficulty finding. It's a little coil which isn't on the board. It's soldered onto the external aerial socket. There's two identical coils, and one has kind of sealed, and the other one is one of those you can either part it and stretch it a bit or compress it a bit, and that's what we ended up doing just to get the third one correct. So we're going through this receiver, and to be honest, the detector was a bit out, but there's nothing more we can get in. It's still this ridiculously high 7 microvolts. That doesn't mean it can't hear lower, but it hears with noise. But I just think that by the time we've got all these adapters and the fact that telescopic error is still in place and all these filters and things which you can't switch out, I just think that's why we get a false reading, because that's not a true reading, because the sets work all right. And you'll see later on in the video when we get the sound back that I then compare it against my own set I've owned from new. So this is about where edit point 7 is going to end. And that's tuning the receiver. So we're just looking at what the sign added, and it's just as dreary. Yes, it's going to be a bit better. The detector's going to be better. We've got rid of the dry joints. But you touch that, get a great improvement. So we'll fill a bit of more of this in. So that's the chart showing the VCO voltage, and yes, it's 4 volts is the other end from the 1.5. I think we're just checking whether squelch has got any adjustment, and it hasn't. But it was working satisfactorily. So retuning the receiver had helped the squelch, but it wasn't wrong before and it isn't wrong now. Just push that capacitor back down over the microchip, otherwise it'll not be going back together. Then I found we were a long way from putting it back together. I couldn't really remember where we started with the VCO. I think it was supposed to be 2.5 start, wasn't it? Or was it 1.5? It was about half a volt low. Anyway, whatever it was correct afterward. It must have been 1.0 or 0.9 or something before. Yeah, that was it. One of the other things was the charge socket on these. The original adapter you could buy for it was 18 volts, 50 milliamps. There isn't a charge circuit in the radio, it's in the adapter, so it's constant current, 50 milliamps for the original battery specified. So be very careful not to put normal 13.8 volts, say at 3 amps, into the charge socket, because it doesn't work like that. We're having a look for a microphone, but we ended up making one. So coming to the end of edit part 8, and when we move on to this 9th edit section, the sound is back. Right, I've had to do a change of tactic. When I tried to test the radio, I found it was doing 2 watts on channel 1, and it was doing 4.5 watts on channel 40. So I've spent a lot of time rebalancing this as best I can. And let's just see the next day. Let's just stick picture in picture on. Let's just see where I've got it to. That's it. So if I switch this on, we need to switch the power supply on. So I'm still at 12.5 volts, and I mentioned that for a good reason. So from cold, it's doing 2.8 watts on channel 20. And it's doing 2.7 watts on channel 40. And he's doing 2.8 watts on channel 1. But then I looked at the service manual again, and this is why I've just taken the lids back off and revisited it. I'm also going to make a mic up so we can use an external mic, and we're also going to get my own, which I've owned from new, one out, and we'll see how this performs, because this was serviced. It wasn't necessarily serviced this week, but it was serviced some time ago. So, look at what it says. So it's 12.5 volts. And then it says plus or minus 15%. So add 15% to that, it's 14.3 volts. So you can run it off a car at 13.8. Now, I'm going to switch the power supply to 13.8 volts, so I've still serviced it at 12.5, which is the right thing to do. So all the adjustments at 12.5 volts. But let's see what happens when I put it at 13.8. And now, as long as the output power doesn't go above like 4.1 or something, if it does that, let's see what happens. I haven't pressed the 24 volt button by mistake. So channel 20, let's see what happens now. I've put it on the 30 watt range because it's obviously going to be greater. So we're looking for 4 watts being there. It's 3. Let's go back to the 3 watt range. It's over, yeah. So it's a good 3, it's like 3.2. So let's go to the channel 40. It's good 3 there. No, it doesn't like this. It's not locking properly. So something, I had to take these shield plates back off. Something is minutely out on one of these early stages. Now then, what I'm going to do is I'm going to put this screwdriver, not to adjust it, but to see what happens, because one of them is on the edge. So let's go back to, so all set up perfectly, but something is on the edge. Just out of interest, what channel does it, let's put it on channel 35. No, it's not doing work there. 30, it's not doing there. 20, it's working. 25, look, plays up at channel 30. So back to transmitter alignment. It was L3T789. L3T789, and then those ones which I've balanced, L5 and 6. So here's today's tip. This is going to affect it, you see. So I'm going to put that near that one. Nothing's happened. So we'll put it on the 3 watt scale. So you can see it's only doing 120 milliwatts. 5. I've already forgotten. Was it 579? L3, T7, 8 and 9. So T7, 8 and 9. Right, back into transmit. It's that one. Do it again. Let's try that one. No. No. It's that one. So going back to channel 20. Just check these others. I'm always saying these things are interactive. So it's keying up straight away. Just to make it easy, we'll put it on 3 watt scale, so it's banging across. So we'll go over to channel 30, it's banging across. We'll go over to channel 40, it's banging across. Channel 1, it's banging across. So not only have we balanced it, we've now reset the earlier stages. Just out of interest, what's the power actually doing? Obviously I've warmed it up now. it's doing about 3.2 watts. So it's in spec. I'm going to now lower the voltage to back to 12.4, and let's just see that it's transmitting. I'll again put it onto the 3 watt scale, so we've got just under 3 watts there. Just under 3 watts there. Just under 3 watts there. So we've cracked it. It's working at all the voltages that it says it should. Out of interest, I wonder if it works at 9 point something, our other option. Now, let's think about this. If it's 12.5 times 15, where's the percent button? Minus. I'll try that again. 12.5 times 15% minus is 10.62 is the lowest it should work on. So we're at 9 volts. I'm not going to alter it from that, but just out of interest, just for the giggles, let's see what happens. So channel 20, it's doing just over 1 watt. It's not locking properly on channel 40, but it is locking on channel 1. Now, let's just see which one's affecting that, because we can make this even better, can't we? Is it that one? It is. Once again, it's that one. Let's try again. That one affects it too. Right, I've just given that the very, very slightest touch, T5. Let's check it locks on channel 1. It does. 40, it does. 1, it does. 20, it does. Let's go back to 13.8 volts. Don't do this at the factory, you know. Wax across. Wax across. Wax across. That's it. Really, really fine-tuned. I'm going to put the shield plate back on. And you know what? We're going to do the same again. Switch it back on. So at 13.8 volts. Wax across. And again. And again. 9 volts. So it's not even supposed to work at 9 volts. Just under 1 watt. Yep. Yep. Okay. Go back to 12.5 volts. Excellent. Well, I'm glad that's over. It's still rubbish received, but as I say, I think this is a flawed test with all the adapters, and that 3 watts could well be more than that for the same reason, but you tend to have less losses in receive than you do on transmit. So in this kind of situation with the adapter tree, just going to check deviation one more time. Wallow. That's a bit lower than I expected. We'll come back to that. What I'm going to do is we're just going to put I'll have to reset this signal generator because I've only just put it back on. So, you know, on the face of it, the sensitivity is crummy, but I don't think it's faulty. There we go, we're on frequency. So 1 microvolt. Can hardly hear it. 3 microvolts. I'll put. Yeah, we can hear it. I'm going to swap to the other set. Well, this is my own set, owned from new. And let's look at the where we've got to be. Oh, I need to be 1 kilohertz tone. So on mine, it's a crummy 7 microvolts for 12 decibel synad. So let's have a look at what the customer's is. Oh, it's 7, exactly the same. So let's do, there's 10. I'll put the synad meter on. You've got the synad meter on. Yeah, that's right. It is 5.2 and a bit. So that's 5.5. Mine's just vaguely better. And then for 20, we can get 20 out of it. It is 15, 16, 17. And the customer's is 18. Oh, sorry, I'm looking at the wrong thing. Yeah, it's 18, exactly the same. So mine's 17, the customer's is 18. So just as crummy. Let's look at transmit power on mine. So remember, this has been tuned. It's 2.8 watts. Customers is 3.1. Channel 40. 2.5. Channel 1. 2.9. And again, touching the metalwork does improve it. So, I mean, how can you do that when you're holding the thing? If they'd have put the range boost side panels on like they had the previous model, it would work better. I don't think this is going to work badly, but I just want to illustrate that this is why we have brand new samples of every model ever made of UK legal CB radios, and that's why there's 400 sets. Though I think we're not going to be taking new sets in the future, as I will be retiring in about 6 years. And they get worse. I have to think, why waste my money on sets that get worse and worse, but have sillier and sillier menus? So, brilliant. I'm glad I did that. We'll make up a mic for that. And I'll pause the video and I'll put my sample set back on the shelf. Right, so there we go, finished. Put the lids back on, screwed it up, and put that. Oh, we'll use the extension speaker when we do the on the air test. So hopefully it'll work round scratchy corner and all that. We'll find out. As a hand portable, they do work well. Not as well as the previous models because of the no range boost side panels and a shorter aerial. But you know, if you could remove the telescopic when you're doing these tests, if you could remove all the rest of the gubbins that's dragging on it, we wouldn't have these rubbish results, because the set isn't as rubbish as the results show. Right, we'll put the deviation meter on. So just as a final, wallow, we're getting a peak of 2.5, and with the external mic, wallow, we're getting a peak of 2.5. Let's put our talkie-walkie on. Testing 1 2, testing 1 2 3 4 5 5 4 3 2 1. Remember, I say these clip-on voice peaks. It's the way they are. They sound like a Bannerton Route 66 on the air. 1 2 3 4 5 5 4 3 2 1. So before, I think we've found the internal audio is punchier than the standard replacement mic, but we're going to do the tests on the standard replacement mic, and then at the end we will go to the internal mic, because otherwise I've got this on the bench and I'm picking it up and all that. So that's why I've gone to the expense of making up a realistic test mic. So I've put about 4 hours into that. Mr. Chippie's put about an hour into it, and you know, It hasn't played up with its dry joints since that's been done. It's played up with the alignment of the transmitter, as you've seen, and by going over those voltage ranges and having little tricks like just applying a bit of metal towards those coils, we can see which one is just slightly out of alignment. And for this to work at 9 volts is well under what it's supposed to do, so that's really, really good. So it's a good result, but it doesn't show as being good on the test instruments. So I'll plug it into the roof aerial. Doubt we'll hear any of the bad buddies in Nottingham. One on a Roger. I'm going to run this at 12.5 volts on our test, so it's doing about 3 watts, not at 13.8. Bit of interference. These don't have the crystal filters that the previous model had. Foreign interference, perhaps there's a bit of a lift on. 19 a Roger. Now, absolutely diddly squat on. So let's just run through our clipboard, make sure nothing's been missed. So we came to the conclusion that it was about 2.9 watts there and 2.8 watts there. We can do a final current check. I'll do it into the aerial. I know that's not what we ought to be doing, but we'll do it into the aerial because that's what's connected at the moment. 790 milliamps. I'm going to have to do it into the test set. So we're doing a little bit more power, and it's possibly drawing less current because it's aligned right. It's not, apart from the deviation, that hadn't been fiddled with. 873. So it's gone up a bit. So we didn't check that before. Good. We're done. Just put the aerial back. And Bob could be our uncle, as they say. There we are. So thanks for watching. I hope it's not been too long. I don't know what I'm going to edit it down to. We're starting off at 4 hours. I don't think it's going to be 4 hours when we've done. Oh, I know what. You know when we were on 9 volts and we pressed transmit? I wonder if it shows low bat. No. No, it doesn't. I don't know when the low battery comes on. And I don't want to alter the power supply because it'll affect the memories. There we go. Thanks for watching.